Good morning, afternoon, evening. It depends where you are, and happy Pi Day. I'm Ettore Volpicelli. Nice to have you here today. This is part of a series of live hands-on lab that we are having with our partner Ampere, and it's just to celebrate this day together. Someone is celebrating scientists or great thinkers, but we want to celebrate you that are curious, that wants to get deep dive into the technology, into the stuff that we are able to share with you today. So move on. I want to say that I'm based in Milan, in Italy. I have a wonderful cake today to celebrate. I will try to eat during the session. I'm joking. But again, if you are around in Milan, I will post on the Slack channel and into the chat the address of our Oracle Customer Visit Center. So if you want to join, it will be something fun if someone will join, I don't know, to have a slice of the cake. But now move on. To actually perform the hands-on lab together with our speakers today, you will need an Oracle Cloud account. If you don't own already one, here you have the link that I'm going to share also in chat, and you can get the possibility to rise and subscribe for an Oracle Cloud free tier account with a special promo. So we are going to give you $500 in Oracle Cloud credits today to experiment and test our Oracle Cloud services. And how we are going to interact during the event and also after the event, because the conversation will continue on our public workspace on Oracle DevRel. So here you have the link. Also, this one I'm going to share in chat. And there is a dedicated channel, Pi Day 2023. Please join and raise your question there, but you can use also the Q&A functionality here on Zoom or the chat. We will have Iwan that will monitor with me, and then we will have two speakers today, Peter Pouliot from Ampere Computing, Developer Advocate, and Eli Schilling from Oracle, Developer Advocate and Head of Tech Content. So let's say, from my side, Ettore Volpicelli is everything. See you later. I'm going to eat the cake. And guys, enjoy. Eli, the ball is yours.
Excellent. Thank you, Ettore, and welcome everyone. Great to see all the folks here in the session today. Let me go ahead and just share my screen, and we're going to jump right in. So this is our Zero to Cloud native app in 60 minutes in celebration of Pi Day. So hopefully everyone is all settled in and ready to rock and roll for today. As mentioned, please use the Q&A. If you have any questions, join us in Slack. We can continue the conversation there. And I'm just going to kind of jump right in here. A couple fun facts. So, why are we partnering with Ampere on this session today? We've got a pretty solid, long-standing partnership with them. Let's see. ARM processors have been around for a while. 180 billion deployed across, mobile devices and IoT devices and other things. And it's through with the help of Ampere that it's been able to evolve the technology into being data center and cloud ready. So for hyperscaler capabilities, we can, really have a rock solid processor with consistent, reliable performance and some pretty extreme scalability. So speaking of scalability, we have some of the highest core density with the Ultra processors from Ampere. We'll show you just here in a minute, but essentially you can pick and choose when you deploy an Ampere compute resource on OCI from 1 to 80 cores on the VM side, and for up at 160 cores if you're deploying a bare metal compute instance. So much like you would choose the toppings on your pizza or your pie, if you will, you simply get to pick and choose exactly how that shape gets rolled out. And then, of course, if you're spinning up an always free OCI account, you're going to get 4 of those ARM cores always free, along with 24 gigs of RAM. Couple of fun facts before I jump into the next slide here. It was 1998 when Pi Day was first officially recognized by a physicist in California. And then it was about, I think, 2009 that the US government decided to make it an actual holiday. So here we go with our fun holidays over here. On the Oracle Cloud side, whether you are brand new or have poked around a little bit, you may have noticed that we've got a pretty broad ecosystem of services, of third-party tools, partnerships. It is through other partnerships with organizations like Jenkins and GitLab and Ampere and Oracle working together to really continue to evolve these ARM-based cloud processors. So we're going to poke around a little bit today. We'll use some Terraform. We'll play with the OCI Cloud Shell a little bit, and then we're going to be deploying our lab environment onto an Ampere-based compute instance inside of a virtual network. I'll show kind of how that looks before we jump in. And of course, there's a bunch of other things you could be doing, and maybe we'll come back with a part 2 down the road. But because we are playing with containers today, there's always the option to deploy to a managed Kubernetes service. We have a container instances service that could be leveraged as well. Other things that we'll talk about these. Peter will touch on these a little bit later as well. Options to evolve and continue to enhance your cloud native applications. So that said, there are 3 options to deploy your infrastructure today. Once you get logged into your cloud account, you can simply use the web UI. We'll deploy a virtual network and a compute resource. I've written some Terraform for you, so you can use the resource manager service. We'll drop the Terraform in there and wait for about 90 seconds. It will spin up all the resources we need. I've also provided all of the command line commands that would be necessary. You can run those right inside of Cloud Shell in the web UI, and it will spin up all the resources that you need to run this lab. While you're thinking about which route to take, I'm going to do just a quick demo. And while I do that, I'm going to leave you with the QR code. So the top bit.ly link is going to take you to the instruction set. I'll pass it over to Peter here in just a minute, but you'll see all of the instructions are out here on GitHub. We have the infrastructure deployment. You can pick sort of a choose your own adventure that'll deploy the resources, and then Peter will take it from there. So let me just show a couple things really quick. If we go into our compute resources, I always like to showcase what the Ampere shapes look like. Once we grab the Ampere-based processor, you'll notice it's always free, and it's really simple just to say, you know what, I want X number of processors, Y amount of RAM, and of course we can kind of move those around. So if you need just a couple of cores and a whole bunch of RAM to run whatever it is your workload entails, you can absolutely be flexible in that regard. On the bare metal side, these are not part of the always free. However, you can spin up a 160 core with 1 terabyte of RAM bare metal instance running Ampere if you needed that for your workload. All right. So as I mentioned earlier, one of the options is Cloud Shell. We'll pull this up here just for a minute while I navigate over to Developer Services and Resource Manager. Go to my stacks. Cloud Shell is a nice little integrated terminal. It has a lot of tools. It has built-in authentication based on the logged-in user, so no extra credentials to assign. But one of the things that we will need for this session is an SSH key pair to log into our server. If you're going to use the web UI, you have the option of downloading the key pair. We'll create one for you when you create the compute instance. If you're using Terraform or you're using the CLI, you will need to create a key pair. So we'll just run a quick SSH keygen that is in the instructions, and we'll have the key pair handy. I've already got one running, so I'm just going to leave this and create my stack. All right. So the zip file or the Terraform that I've created is in a zip file. It's in the GitHub repo as well. So you can download that from a link in the instructions. We'll just browse out to the PyDay main zip file, and you'll see here, it reads through all the Terraform. There is a schema YAML file in there if you decide to poke around a little bit, and you'll see that we have the configuration for the stack details. We're going to deploy an Ampere A1 flexible shape, and then all of the info. Next tab. All of the values have been predefined. So your virtual cloud network name, CIDR, amount of CPU and memory for your compute resource. The only thing you need to do here is add your public SSH key pair. So I'm going to skip that right now just so I don't paste my key into a public domain. But you would put your SSH key, you'll click next. And the last thing here is just to make sure you click the run apply, and we would hit create. With that, Resource Manager is going to take all of that Terraform, look at the declarations, and create the necessary resources to run this environment. And then once it's done, it is going to return to you the public IP address of your compute resource. At that point, you would SSH in, and you are ready to go on to the next step. All right. So we'll give just a minute while folks sort of orient. Hopefully everyone's been able to get to the workshop instructions. As I mentioned here, the other option, if you wanted to do the CLI, you can pretty much just copy and paste all of the commands along the way to create the resources, or copy them into a shell script and just run it once. Kind of depends on your preference, but very much a choose your own adventure story today. All right. With that, I'm going to pass it over to my friend and colleague, Peter at Ampere. Peter, take it away.
Great. Thank you. I'm going to share my screen. All right. Well, hello, everybody. My name is Peter Pouliot from Ampere Computing. I'm a developer advocate. And today, we're here to talk about, Pi Day, and bringing you from zero to cloud native in hopefully less than 60 minutes. So what are we going to talk about? Well, we're going to start with some surprising appearances of Pi that were provided by a colleague of mine. So I will say he's a math whiz, and I'm out of my league with some of that. We're going to also talk about something I know a little more about, which is what does cloud native mean? And then we're going to start by getting started with an environment using Docker Compose. And we're going to evolve that environment over time by adding a proxy. We're going to talk about load balancing and add a load balancer. We're also going to talk about the importance of caching. And then we'll follow up at the end with what's next. So here's some surprising occurrences of Pi. So e to the square root of 163 of Pi is almost an integer. Why? Because 163 is a Heginger number, and the Q expansion of the J invariant is, well, yeah, what that says. So I'm out of my league, but I'm sure you can look this stuff up and find out more information about Heginger numbers and what they have to do with Pi. As my colleague said, it's complicated. The second is the probability of two random positive integers are relatively prime, meaning they have a GCD of 1. This is related to the Basel problem result. So another interesting uniqueness of Pi. So now something a little more aligned with what I like to talk about, and that's all things cloud native. So what does cloud native mean? Well, if we think about traditional applications or enterprise applications, right, that were typically architected to run on a whole server. For example, people hear the word 3-tier application, right? Those things would typically have a database, an application server, and maybe a client for display and a user interface. And traditionally, those things would run on different pieces of hardware. Cloud native applications are disintegrated into many small components. Typically, we call those microservices, and those are masked behind a proxy or an API gateway. Clients interact with these applications using APIs, and application components tend to be isolated from each other, typically in things like containers. They may have their own data storage and may interact with each other over a message queue. So in this example, you see, this would be a typical example of a cloud native web service using microservices. You have a collection of open protocols like JSON, HTTP, WebSockets, right? And standards for data exchange between apps. We have client access front-end services using things like XML, JSON. right? Accessing those endpoints. User traffic is routed to the back end using load balancers through the API gateways. And they're modularly, loosely coupled services to implement the business logic in those microservice layers. And then the back end storage, right, will be either SQL or NoSQL storage components to store those different elements. So here's another great example that I have some experience with, and it's a project called Death Star Bench. Specifically, Death Star Bench represents a series of different popular web services, one for social networking, a media service, and an e-commerce service, IoT, and a banking site. It essentially is a great example of a more modern approach. It deploys these services in over 30 components, and these, include multiple types of data storage and object caches, and many application components that serve each a small purpose. They communicate with each other using, different APIs, and all this complexity is hidden behind, a proxy like nginx, right? That nginx manages the connections to and from the innards of the application, to the either mobile client or web-based user client, that's being presented that information. In the languages, some of the languages that are used in Death Star Bench are, .NET, Lua, Python, C++. So, but essentially, the one that we're specifically talking about in this case is the social networking application. So, as you can see by the example, there's multiple sharded MongoDB elements, Redis caches, and sharded mem caches, as well as other business logic implemented in the middle. And as we said before, we have the nginx, providing the front end connectivity to those services with a load balancing implementation as well. So let's talk about our goal today. So today we're going to start on a journey towards understanding how cloud native applications are put together to enable scaling across multiple compute nodes. Our end goal is to have 6 containers running in a single 4 CPU virtual machine, running on an Ampere A1 instance in Oracle Cloud. And you can, as we said, all this can be done today in the OCI free tier. We'll start simply with a WordPress container and a MySQL database instance. And we'll progressively evolve our WordPress instance to be more cloud native by adding an nginx proxy, which will enable us to evolve the architecture. Load balancing across 3 WordPress instances, and then finally enabling a Redis cache to store some objects through and utilize a WordPress plugin. Now, if we look at the map here provided, this will include a LAMP stack, essentially a LAMP stack deployment for WordPress. We're going to utilize Docker Compose, which is a really way for people who want to learn how to get started in a cloud, utilizing cloud native technologies to do it on your workstation. And you can then take that and, evolve that over time to, as we're going to show you here, to servers in the cloud, as well as, even beyond that to translating it into things like Kubernetes. So it's a great way to learn, and I myself, through the years and even now continue to use it to quickly and easily bolt together complex, workloads like we're trying to evolve today. So, we're going to take this simple multi-tier web application. We're going to make sure that each component, we're going to use containers, so each component is, running isolated. We're going to scale it up to use multiple front ends. And do some other things, but essentially this is going to be MySQL with WordPress and PHP programming language with a web server front end. So to get started, you'll need to install Git and have that tooling on your local machine, and then you'll need to clone the repository located here from the Ampere Computing GitHub repository. So that's github.com/amperecomputing/pi-day-tutorial. So all the instructions are also included in the README. So next we're going to talk about starting a Docker Compose application and give you a little more information about that. So, for the tutorial, we use Docker containers. A Docker container is an industry standard, that defines, how how you package the software and things within that unit of confinement. Docker is it's a popular suite of tools that you can utilize on your workstation, and it made it really easy for developers to take all the dependencies of software and package it in a way that they can easily share it in that format, and then distribute it and then scale it. So, the way I like to think about it is, Docker is essentially three things. It's a common format to describe containers and package applications with all the runtime components that they need. So all the dependencies are all bundled and included in the container itself. It also includes a runtime that allows you to, run those containers on your developer workstation or on a server. And the third thing it includes is a suite of tools that allows you to easily build and share these containers. Today we use the Docker Compose tool to start, stop, and interact with our WordPress application. And Docker Compose makes it easy, to describe a multi-component application and run it in a single file. And it allows you to, take that description and keep it in a single file and allow you to change the different elements to configure it as you go along. So to install Docker, on Oracle Linux, you can run the following commands, for a suite, sudo and install the tools using DNF. We can add the repository for the upstream Docker repository, use DNF to install the Docker engine, the Docker client, and containerd. And then we can use curl to download the Docker Compose binary. And then essentially, the last command is used to make it executable and move it into the right location. So once we do all that stuff and you have Docker running and you have a recent version of Docker Compose and have downloaded the Git repository, you're going to have everything you need to get going. So now we can continue. So to give you a little more information, when we enter the Git directory that we cloned onto our local machine, we should be able to CD into a folder under that directory called WordPress 1. And that's where our first step of all this stuff is going to begin. The directory is going to contain one file in addition to some tutorial instructions. That file is called dockercompose.yaml. As I mentioned earlier, that's how we're going to define the containers that are going to be used and how we're essentially going to execute them and bolt them together to launch our WordPress application. So if everybody can go in that, they'll see, and they'll be able to see the Docker Compose services described, the Docker images, the volumes mapping to the folders that we're going to use, and the environment variables used for the configuration as well. So in this case, as I mentioned, we're going to use some volumes that are going to map to folders on the local host. Those are going to map to paths inside the container, and this way is commonly how applications and databases store their state when you use a containerized application. Once you restart the container, in this case, if it's using map volumes, then it will persist changes. If you did not use storage volumes when you're creating applications like this, then all the changes made inside the container will be lost if you delete it and restart it. So let's continue to move on. Okay. So as I said, today we're going to start a journey on, oh, did I go backwards? Hold on. So I'll make sure. Nope. Yep. Today we're going to start a journey on how to understand cloud native applications. They're put together and understand how they're put together to enable scaling across multiple compute nodes. And let's move on to the next and actually start the first container. So I'm going to switch to a terminal. And we're going to switch to here, if everybody can see that. Someone confirm that they can see my terminal properly.
Yes, Mark.
Yeah, looks
Yes,
great.
yes.
So here we are, as I mentioned, in the first WordPress directory. To use the Docker compose command, it's relatively simple. You can just basically type Docker compose up -d, and the D will set it in the background. So if you didn't put the D, what it'll do is it'll show you the logs and all the things that will be happening kind of as it's starting up. The first time we run it, it will pull all the container images down from the container repository. In this case, it's going to be the Docker Hub. Yeah, I believe they're all coming from the Docker Hub. And essentially, once it does that, then it's gonna start them and launch them on this instance. So we will do this, and as we can see, it just launched. So I did do a little prep prior where it pulled it down. So now what we're going to do is we're going to move to a browser and see the actual instance and the WordPress instance starting. So here's the started WordPress instance from those containers. And as I mentioned before, if we do this, we can see both our database instance running, database container instance running, and the actual container instance of the WordPress running. So once again, if we go back, here it is. We're going to click on English. We're going to put PyDay tutorial. Going to put my username. Going to copy that. Put my email. And we will install WordPress. Sure, we'll log in. So there we have a working instance of WordPress. We go, there's the default blog. So now that's the first phase, and let's move on to the next. So before we do that, I'll show you how to bring it down. So much like how we brought up the first one, we went Docker compose up. In this case, to bring down the container workloads, we're going to type Docker compose down. That will stop them. And now we'll move back to the slides. Ooh, I have to get out of full screen, I think. There we go. There we go. All right, let's move ahead. All right, so step 2. So in step 2, we're going to add an nginx proxy, and this will hide the internal application. So the actual web application of WordPress, it'll hide the database and kind of give it some protection so that's not to expose it out to the open to the rest of the world, so to speak. And this enables us, essentially, once we hide our internal application from the end user, all the traffic will be proxied through nginx to the final destination. And this will enable us to load balance across multiple instances eventually. It'll allow us also to cache files to be returned from nginx rather than from other services. And it'll also serve multiple services from the same hostname. We'll also eventually restore a database dump of a blog contained in this tutorial to show how easy it is to reload a database from backup. So, abstract application architecture behind a proxy server. This is a great, map to give you an example of what that looks like. The inbound request will come through, and then the proxy will hand it off to the WordPress and then return it to the client. So this way, it gives you, as I said, a nice layer of the beginning of a layer of protection in the whole application architecture. So what's nginx? Well, nginx is it's a popular web server, which can also be used as a load balancer and a reverse proxy cache. It can be added, adding a proxy enables us to evolve the application architecture without changing how the user interacts with the service. Nginx is one of the most popular web servers in the world, and it's commonly used both as the load balancer and the reverse proxy cache. So, as I mentioned, we're going to have to make some changes to the database. So, before running Docker Compose this time, we're going to replace all the IP addresses from the VM where our database was generated with our public cloud IP addresses. You should be able to obtain that public cloud IP addresses either from the output of the Terraform code or from the OCI Cloud Console or from your Cloud Shell if you ran some of those commands from there. WordPress can be kind of annoying because inside of its internal configuration, it uses an IP address, and it will not work unless we make this change. So we're gonna, as I mentioned, load a backup from a different WordPress instance, and then Docker will use a special folder in Docker entry.point.d to bootstrap our instance, and it'll do all this after we make this change. So if you're logged into your instance that you created in Eli's previous steps, if you go to the PyDay tutorial code directory and cd into the MySQL DB directory and run the sed command with that IP address, the 129.213.187.155, remembering to escape out the periods with that slash, and then replacing where it says your IP address here with the actual IP address that you got from your console output, and remembering to also escape the periods in the same way, and then closing with the closing bracket and the G and the end tick. And if you run that, that'll basically make all the changes necessary in the SQL to ensure that the database will come up properly in the next step. Once we're done that, you can cd into the WordPress 2 directory, and we will continue. So let's talk a little bit first, a little more about loading the database backup. For this step, we use a special folder, Docker entry.point.d, defined in the volumes map to load a database backup file to show how easy that process is. Future steps are going to use the same database that we modified already to make it easy. WordPress will also wait for the database to pass a health check before starting. And as I said, this all happens when we run Docker Compose up in the WordPress 2 directory. That backup database will automatically be loaded. The health check will run because it's included in the file, and it'll be used to make sure that we don't start our WordPress instance before the database processes haven't been completed. All these steps should take about 20 seconds to complete. And then once again, let's talk a little bit more about what would be needed to, actually, let's flip to the console first. I'm going to make it full screen again. We're going to cd to the WordPress 2 directory. Let's check real quick the docker compose.yaml. As we can see, we're passing in some variables. We're passing in our volumes, the Docker entry.d, as was mentioned. And we see the health check test located right there under the database. So let's go ahead and start it, much like we did before. Docker compose up-d. It's launching the containers. As we said, it's probably going to take about 20 seconds. Maybe more. There we go. Now, to make this easier, I'm going to get on a full screen here, switch over to our web browser again. And now, when we load this, we should see. All right. So that database also contained a preloaded blog post describing all the steps that we're talking about here today. So that's what we see here. If we go, I'm going to look in the console and see what we see. Let me refresh this. We're going to log in using PyDay with a password of 3.14592. And so if we look now, here's the administration console. As I mentioned, there's the blog post. Let's check out the running container instances, what it looks like. So there we have our cache proxy running, our nginx proxy, our WordPress instance, and also our database. So now we can, that we have that working, we can do the same steps as we mentioned in the first one, to bring it down to Docker compose down. That'll stop it. And then we can now move on to the third step. All right. So as we showed, previously, there's no, nothing really changed from a user perspective. The website still fully functioned much like the first time, with the exception of we pre-populated more content. And at the end, we had the extra running container for the cache. So now what we want to do is add some load balancing to the mix. We're going to create several WordPress instances, and we're going to use nginx to load balance and distribute that traffic across those WordPress instances. In this case, because we're on a single VM, that's the major constraint. But in a clustered application, the load balancing would happen across multiple nodes, and that's one of the best ways to scale. In this case, we're going to load balance it across the 3 container instances that we're going to create using the Docker Compose file. So this is what the architecture will look like. Some of the benefits of load balancing, spreading that traffic across multiple loads, allows you to be able to respond to more inbound requests. It distributes that load across them. There's different logic in some cases, depending upon the load balancers that can be used to determine how that is spread. By default, nginx does a great job of load balancing that stuff for you. And that's why it's one of the most popular load balancers used today. So let's move on. As we can see in this, the architecture doesn't change all that much. We add a couple more instances, and then as we saw before, the user interacts with the front end nginx proxy, and then that proxy is going to distribute the load across the WordPress instances. So if we look at the nginx configuration, is going to change a little bit. In this case, we bring down the as we mentioned, we brought down the WordPress 2 folder. For those of you following along, we should move into the WordPress 3 folder. If we look at the configuration file that's included in there, you're going to see something like this. We're defining something called a W3 cluster upstream, and in that we're going to put the names of the containers that will be responding, and then that way anything that hits the default IP address of that will be load balanced across those instances. If you look at the Docker Compose file, you'll see that there'll be 3 identical WordPress containers. And as I said, we're updating the nginx configuration that'll get loaded by those nginx instances. There are a lot of parameters that can be used in an nginx config. As we said, we can send it to a random server. We can send it. In this case, we could do, you could do things like A/B load testing. One of the popular things to do in large web services is things like canary testing, where you use a small subset and send load to it, real load to it, and see how it reacts under that. So this is one of those places where you could, begin to implement those things. In this case, the technology we're using to load balance is a simple round robin, and that'll essentially go one at a time across the 3 WordPress instances, distributing the load in that nature. A lot of times, the concept of round robin distribution could also be achieved some cases with DNS. This is happening, behind that proxy cache. So that way we don't need to do it in DNS. So now we're going to move back to the terminal. And we're already in the WordPress 3 directory. We're going to do docker compose log, docker compose up-d, once again, to launch it. And this is doing, let's all start it up. Okay, so now here, what we're going to do is first we're going to go docker compose logs-f. And this should show us some of the running logs coming out of the container infrastructure. Now, one of the things we want to do to ensure that our load balancing is working is check to see what we can see. So I'm going to also switch now to the browser. And if we come back here, we should see the load balancing beginning to happen. Where did my... losing my browser here. There we go. So let's generate some load by refreshing the page. And as we can see here, the WordPress instances we're getting loaded across the three. There's WordPress 3 instance, WordPress 1 instance, WordPress 2 instance, serving up the content. So the load balancer is working. So that's great. So let's cancel out with a Control-C. Let's quickly just reiterate, look at that docker compose.yaml file real quick. Just to go over again, there's our identical WordPress instances, our database, and once again at the top, the nginx proxy. So now that we've done all three of those, we can move on to the fourth. So before we do that, we should also do a docker compose down to stop all the instances. And then we will also pre-prep by CDing into WordPress 4. All right, now I will go back to our slides. So, as we mentioned, for our final stage of the journey, right, as we evolve our multi-tier application and our cloud-native application, we're going to add a Redis object cache to WordPress. This is going to, part of this, we're going to have to install a caching plugin to deliver, and this is all going to help to deliver static content to unauthenticated users. These two measures will reduce the workload on our WordPress nodes and on our database, and allow us to scale up from about 55 concurrent users of the WordPress application to about 1,600 concurrent users, which is more than most blogs would ever need. So when we look at the change in the architecture now, we're adding an additional Redis cache. We still have the 3 WordPress instances. If we use adding Redis as an object cache and WP Supercache plugin, as I said, will allow us to achieve more performance out of this architecture. What Redis is allowing us to do is it will allow us to cache the PHP objects that are created by the application when users are interacting with it. When an object is needed again, it can get loaded out of the cache rather than having to recreate it. So we're reducing that computational load. And this will also reduce the amount of database queries that hit the backend database and the amount of PHP logic that's needed. WP Supercache, that plugin that's being used, as I said, it will allow us to allow unauthenticated users to get some static content. WordPress is only dynamic for authenticated users, so 99% of blog traffic is authenticated. So so as I said, here we are getting to the end. The caching will help us to accelerate the blog, and it will help us to scale. And it's just an additional Redis container that we're going to be adding to the mix. So we're going to go back to the terminal next. We're going to CD into that, as I mentioned, for those of you who haven't done already, we're going to CD into the WordPress 4 directory. If you haven't brought down WordPress 3, you're going to need to do that or else it will fail. The admin interface is going to stay the same for the WordPress instance. So for those of you who don't remember, it'll be Pi Day with a password of 3.14592. We're going to, as I said, verify that the plugins are there, and we're going to make sure they're installed. And we are also going to then need to do some additional reconfiguring of WordPress to get it to properly use the plugins. So let's CD to the terminal again. And in this case, I've actually done a little bit of prep. So for those of you just starting out, I highly recommend right now, let's do a Docker compose up. -D. And if this is the first time you're running this, it's going to create all the necessary directories and folders and files, because we're mapping that data store back to our local folders, right? So once this is up, we can go, we'll take a look at what it looks like. Didn't need that. So there's the containers running. If we go into now, we're going to have to add some configuration changes here. So if we go into the WordPress directory and we edit wp config, and we go to the bottom, we're going to have to add these lines into that. Now, this file won't be there until you run that for the very first time. Okay. Now, this is what we're going to use. This is actually the configuration that's going to allow us to connect the container, the Redis container, and the port that the application Redis is running on into the WordPress plugins. So this is going to be critical for success in the next step. So once you have those changes added, then we're actually, in order to activate them, we're going to have to Docker compose down again. And then Docker compose up. And once this is done, then we'll then switch to a browser, and we're going to do the rest of the necessary steps there, because we're going to have to add the plugin and then walk through and then a couple of clicks from the plugin interface to actually enable it. So I'm switching back to the browser. We're going to move right here, and let's go to the admin interface. And I'm just going to do a refresh. As you mentioned, that's the same Pi Day 3.14 that was set up in the database. If we log in and go to plugins, and in this case, I had actually already, actually, I don't want that. Sorry. I actually already enabled it earlier. So what you're going to have to do in this case is you're going to have to, for those of you who haven't installed it yet, you're going to have to search for Redis in the search field. And then once you do that, you should see the Redis object cache. Oh, sorry, after clicking new, you should be able to go to search plugins, Redis. It'll find the Redis. You would click on it. It will install it. There'll be some buttons, a button to install it. And then basically once it's installed, there'll be a button to activate it, and it'll come back and essentially be like this. And at that point, the plugin will be activated. So once we have that in place, we can verify, I believe, that it is working properly. And let's check real quick. Oh, We'll verify some things just with the logs, just like we did before, just to see that activities are going. So you can use docker compose logs -f. You can remember to type. And if we go back to our browser, let's just verify some things. You can see it. Put a few refreshes. We see the proxy. We see WordPress getting hit. We see the load balancing occurring. I think you would have to, let's verify. Verify everything's running. There's our Redis cache. So at this point, we have successfully set up a multi-tier WordPress application. We've load balanced it across multiple loads. We've proxied those inbound connections using nginx, and we've added a cache to store a cache in a plugin, WP Supercache, to actually enable Redis caching. So let's move back. And I guess what's next? Well, the next steps that we could do in this case is, we can enable SSL using certbot from Let's Encrypt. You can enable a web access firewall to protect the site from malicious attacks, or layer 7 firewall, right? A lot of it's, necessary today's ecosystem of web security, right? We can continue to do, backup and restore database files. We could add monitoring, and there's a lot of other things we could do to, scale. You could, scale up the Redis instances into a multi-tier a multi-node cluster as well, and do all sorts of things. Go multiple sites. So lots of things you can do, and we'll explore some of those in the future. So as we said in the beginning, if we use this QR code, you can it'll bring you to help you sign up for an OCI free tier where you can find the Ampere A1 instances. If you're looking for more information about Ampere and looking for some of our developer resources, you can mosey on over to amperecomputing.com/solutions and access some Ampere ready software and see what works best on Ampere, what things are available in an open source in the open source ecosystem that we know works great on Ampere. You can assess your stack readiness using some of our workload briefs found at amperecomputing/developer. And you can, and also there you can evaluate, using the right performance and energy metrics, because here at Ampere we believe power matters. And also, feel free to reach out to us at developer@amperecomputing.com. And that QR code right there will also bring you to our developer portal if you can't find it. So, I guess other things, if you want to try it, you can get started using package and tools from your favorite repos like Oracle Cloud Marketplace, Bitnami, GitHub. You can test drive other options in the OCI free tier and check out the accelerator program. And you can find more information about those things at amperecomputing.com, where to try. And also you can leverage some of our tuning guides to optimize your favorite workloads and ensure you're using the right bits at amperecomputing.com/tuning guides. So we'd love to engage with you more. And that's all I have for you today. So thank you for your time, and happy Pi Day. And for everyone, my favorite pie, if I were to have a pie at Array, is a strawberry rhubarb. So at this point, I'll give my screen back to you guys, and open the floor, I guess, for some questions.
Yeah, exactly. Thank you, Peter. Of course, we have a couple of questions that probably we can raise now that you can answer live. For example, we have here, what is the idea behind load balancing in the same instance? I think it's interesting.
Yeah, so in this case, what we were trying to do is showcase, the elements of a cloud native application in the lowest, easiest form factor possible. And that's why we decided to use a single instance. The containers are simulating the idea of multiple nodes at the that would be load balanced across. So, this was a conceptual and more for educational. In the case of this, from an Ampere technology perspective, as we get into larger core counts, from a compute and load balancing that compute workload across those cores, you can think about it as we're not necessarily, we're load balancing that compute power across the cores in the case of doing it on a single instance versus necessarily just thinking about it from a purely network perspective, right? So yeah, that's how I would view the why and how of using a single instance to do this. Partially educational and partially to show load balancing that compute workload.
Perfect. Thank you so much. And of course, guys, Slack, as I mentioned, our workspace is there. So I encourage you to join us. You have the link also in the confirmation email or the reminder email. So the conversation can continue also after the fact. But to have fun, we created also a quiz based on the content that actually we got today by Peter and Eli. I'm going to launch a poll. In the meantime, I'm actually talking about that. So are two of the questions that you will find in this quiz. It's pretty easy. And if you are going there, you can grab this incredible, I love it, digital badge to have on your profile and to celebrate the day. Of course, it's not Marcus Cicero. I have to say, I'm Italian, so I'm pretty close to him. So it's not him, the one behind the pie. So enjoy with this quiz. If you want to take the poll, I will actually share the result live, so you will have already to answer for this quiz at the end of the day. Okay, so let's share the result. The right answer here is the first one is Archimedes of Syracuse. Okay, and about which of the following are particular well suited for the Ampere A1 processor. And yes, everybody, the majority of you, all of the above. So it's a very, very, very incredible processor. Okay, so guys, it's almost everything from my hand. Just last message. Next week, we will have an Oracle Dev Live Level Up event, 4 days, all about cloud native, machine learning, Java, MySQL, data strategy, everything. So I encourage you, even if you are not based in California or US, to get the in-person event, you can attend digitally remotely. Okay, so take a look at our website, developer.oracle.com. You will have all the information also about this event. Again, we are at top of the hour, just in time. Thank you, Peter. Thank you, Eli. Thank you, Iwan. Thank you, Phil, for the support. Contact me. I'm in touch with some of you for the free tier sign up. Again, contact me and I will follow up your request. It was a lovely hour to celebrate the Pi Day. The cake was nice. My colleagues are exactly out of the door here because they want a slice they were connected to. See you soon. Ciao. Bye-bye.
Thanks, everybody.